Hello and welcome to Migrating Legacy JE Applications to vFabric Reference Architecture. In this screencast, we are going to look at the data migration from DayTrader RDBMS into SQLFire. We will explore the DayTrader schema deployed on Apache Derby database and create the Spring Trader schema for SQLFire. After creating the schema, we will demonstrate the use of SQLF commands to load the data into SQLFire and apply SQLFire techniques such as partitioning and replication to data definition language. DayTrader database runs on Apache Derby server on port 1527. Let's connect to our database using IJ tool with the help of JDBC connection string. And let's have a look at the number of tables and the indexes which are part of this DayTrader schema. So these are the tables and indexes which are part of DayTrader schema. Let's have a quick look at the Spring Trader converted data model. Here we have account profile table with profile ID as its primary key, an account table with account ID as its primary key and it references profile ID from account profile. We have quote table with quote ID as its primary key, holding table with holding ID as its primary key. And finally, we have order table with order ID as its primary key and it references holding ID and account ID from holding and account tables respectively. Here is a converted data definition script for Spring Trader. It's a regular SQL, but the key thing here is we are saying that the account table is going to be persistent synchronous. The entire table is going to persist onto disk in a synchronous fashion, and it is partitioned by primary key. That means to say that data within the account table will be partitioned across SQLFire members in a cluster. Account profile will also be going to persist on disk, and same here with the Hibernate sequences. Holding table is partitioned by column, which is account underscore account ID. Same with the orders table, that also is partitioned by the column account underscore account ID. And both of these tables are collocated with account. By collocating these two tables with account, we are forcing the database to store its child rows with a parent. The whole notion of how do we linearly scale the data is to think about the access patterns. Here we are going to assume that by collocating orders with account, we are joining these two tables for the stuff that we are going to access the most often. The general idea is that we are going to take the related entities and group it together and store it together in order to fetch data in a much faster manner by reducing the latency and the execution time. Let's execute the Spring Trader data definition script on SQLFire. Here we have a simple setup of two members in a cluster and a locator service running to identify and discover the members in a distributed system. Let's connect to the SQLFire member and execute the script. Here we have connected to the first member, which is running on port 1529. We'll execute the script here. We have successfully created the tables by executing the script. To ensure that the tables are created, here we are connecting to the other member, which is running on port 1530. To verify the tables and indexes are created properly. Yeah, we have successfully created the tables and indexes. Let's see how we import the data into SQLFire. We have two options to import the data. You can use either SQLFire commands or Apache DDL utils. Here we are going to demonstrate SQLF commands to import data from Apache Derby database into SQLFire. SQLF utility provides several commands that use DDL utils API to export and import schemas and table data. You can use SQLF commands with SQLFire and other JDBC data sources. To use the SQLF export commands with third-party databases, you require JDBC driver and connection URL to that database. Ensure that you have set the class path pointing to the appropriate jar. Here in this case we have set to the Derby client jar and path set to the bin directory of SQLFire installation. To import the data from Derby database into SQLFire, we execute the SQLF command to export the schema and the data into XML file. With this command, we export the entire schema into DayTrader schema.xml file. And with this SQLF command, we export the entire DayTrader data into DayTrader data-xml file. Now we have populated the schema and the entire table data into XMLs. We will execute the SQLF write data to DB command, providing the schema and the data XML as the input to load the data into SQLFire data node. Now that we have successfully imported the data, let's verify by connecting to the other node which is running on port 1530, and let's retrieve the data. Here we go. By this we have successfully completed the data migration from DayTrader RDBMS into SQLFire. Thank you for watching this screencast.